represent the vector addition. So basically it need to apply the triangular and any of the vector addition law when two vectors act at a point and they have in different direction, that we need a systematic method to find out the resultant vectors. So triangular law, it states that if two vectors are represented in a magnitude and direction by two sides of a triangle in order, then the third sides or third arm of the triangle in reverse order represent the resultant of the two vectors. So if the force acts simultaneously on a particle be represented in magnitude and direction by two sides of a triangle, then their resultant may be represented in magnitude and direction by third side of triangle taken in opposite order. So here OA that represent by a P vector and another vector A represent another vector Q represented A to B direction it is this, then the third term, that is BO, represent with R, that is our resultant vector, and the direction of resultant vector is this. So it is in reverse order. So the as we discussed in last one of video about the parallelogram law, so that is also the vector addition to find out the resultant vector of two vector who having the direction is different. So formula for finding the with triangle law is the same, but here the two vectors, if they are in a order and represent two arms of a triangle, then we can apply the triangle law. So and the phi is the angle between the resultant and one of the vector. So it is very easy to find it. So we have this from the vector addition, simple, that in a triangle vector A, B and OA, AB and BO, so we can have resultant R is equal to P plus Q. So now to find out the resultant vector R value in terms of uh, P and Q, we have extending this OA up to C, and then we are draw the perpendicular BC, this perpendicular to OC. So this angle will be 90, and let's say this angle is assume this angle as theta. So now from triangle, simple, this OCB, that is OCB, that entire triangle, here it is 90. So once you can write that we have studied that OB square, that OB square is equal to OC square plus BC square, means this arm square plus this arm is equal to this. Then we have just simple analyze. If we do that OC, here we can see that this down this OC, this is basically the summation of OA plus AC. So we are writing here that OA plus AC, and now from the triangle, if we say this O, B and A, so this triangle, if we consider ACB, this triangle, then sin theta we can use the formula BC divided by AB, and so we can find out that sin theta is that BC is equal to Q sin theta, and for other way we can find out the cos theta, that means the AC value is equal to Q cos theta. So if we just combine this equation 2 and 3 in equation 1 easily once, we can get this. So our OB is basically R square OA plus AC, that means P square plus Q square cos theta plus 2PQ cos theta plus Q square sin theta. So with this simple analyze, just we are getting r square is equal to p square plus q square sin square theta plus cos square theta plus 2pq cos theta. We know that this part sin square theta plus cos square theta is equal to this is basically equal to 1. So we can find out the r value is p square plus q square plus 2pq cos theta. So this is the resultant value of using the trigonal law. So using the parallelogram law also, resultant formula is the same, p square plus q square plus 2pq cos theta. This is the magnitude of the resultant. So now direction, let the phi be the angle made resultant and p. So this is our p vector, and resultant was the third arm, that is r, and the angle is this angle is phi. So we have another vector is this, so that is, let's say, q. Then one can find out the resultant r with the p. Then from this we can find out tan phi. So that is basically the tan phi is equal to q sin theta divided by p plus q cos theta, which is the direction of the resultant. If we take the other one, that this angle is in between with the q vector, then we can find out. So if we summarize, the resultant r, that is basically the p square plus q square plus 2pq cos theta. So now for finding out the direction, if this is the resultant hour and this is one vector p, and then this is the alpha or phi, then we have seen that this we can find out that as tan alpha is equal to is q sin theta divided by p plus q cos theta. Now if we define this alpha angle in between another vector q with respect to resultant, we can find out that tan alpha is equal to p sin theta divided by q plus p cos theta. So this is the direction of the resultant vector, the direction of the resultant vector with respect to any of the vectors. So now if we summarize that the lecture triangular law, that is basically the representation of two forces which are acting in magnitude and direction by two adjacent sides of a triangle. Then the third side of the triangle in reverse order is represent as the resultant force. It is a graphical method to use to find out the resultant of two forces acting at a point. The magnitude of direction of resultant, we have, which we use the formula, just use the normal principles of geometry, laws of cosine and the law of sines. And it is especially useful when the angle between two forces is known and the exact direction of the resultant is required. So triangle law is a special case of parallelogram law, applicable when the forces are added tip to tail. Forces are added tip to tell. And last is that it widely used in engineering student, in particular for civil and mechanical engineering, to solve problem related to equilibrium, tension in cable, and the structural analysis. So triangle, we are winding up here today with the triangular law with a short lecture. So yeah, I hope it will helpful to you for a short, a simple understanding of triangle law. It will be, this formula will be useful for solving the problem in a direct method, or can be verified with the 2 and 3 dimensional representation of the force. And if you like the video lecture, please click on the like button. And if you like to get more lectures, so please subscribe my channel. Thank you very much. Thank you.